February the 25th, 2026. Guys, a couple of weeks ago, we did two videos talking about the newly discovered Comet maps. Technically, it's C/2026A1. And this is the new JPL model, and it hasn't changed. And this was today, but I've got it set, if you notice the timestamp, guys, on April 4th. And these events are April 4th and the 5th. Shows it hitting the sun here, and then the next move into any of the models skips through the data from here to when it comes out over here. And I think that's the confusion. And one of the people that I really enjoy watching, one is just got such a calm nature, is Ray's astrophotography. And he mentioned 3 different models in his videos. And I think we're going to cover all 3 of the models he was talking about, including one of the 3 was an impact, and then 100,000 miles above the sun, one maybe 200,000 or 300,000 miles above the sun. Now let's look at some of that data. Notice on the 4th, there's your date, and the sun distance is 7.9 E minus 3 AU. 1 AU is 100 million miles. And so let's take a look at that. If we translate it, that 799 E minus 3 is 742,716.9 miles. That's how far it is at that point to the center of the sun. Now, that means you're looking at, that's above about 300,000 miles above the surface, because everything's measured from the center of the sun. All the distances that you get on any type of information like this, astronomical units, is from the center of the object, whatever it is. So here's at 742.7. So this is well above it, and that's what the model shows. It's well above it, that 430-something thousand odd miles to the center of the sun. 432,300, that's what it is, the radius. And so the next one we're going to move, and that's exactly where the model jumps to. There's no in-between point to get the measurement from here to where it supposedly exits the other side of the sun. Remember, 742,000 miles at this point. That would put it about 310,000 or so miles above the sun. Now again, this is going to match all 3 data points that Ray was talking about. Here's the second one, and there's no data point between the pre-entry that we just looked at and where it is now. 1 hour later, that's how fast it's traveling. If it follows this path right there, guys, all we will see is explosions on the sun, just like we've seen in other comets. But this thing's going to be much bigger than what we normally see. So what we don't know the data points, and that's why I think Ray was saying 3 points. Here's a couple 100,000 to 100,000 miles above the sun's surface. Then the pre-entry 300,000 before it hits that, and then what we're looking at here, again, 549E3, notice the arrow is 510.32. And so we're at 432,000 to the center. So we're less than 100,000 miles above the surface of the sun here. That matches the 3 data points pretty close. But we don't have the middle point, and we'll look at that. And that's important, because if they're taking, and what will happen is that you'll look at the close approach data on the JPL model, guys, and it's going to give you this data point we're looking at and the one before the sun's entry. And so it's not going to show us, even on the JPL data, the entry data, the distance from the center of the sun through that interior line. And there's where they're making their mistake. That data arc should have stopped right in the top center of where we're looking at now. Now this is an imaginary, very poorly drawn arc through the center that there's not there. And that's the data points we don't have. Again, the green dot, we're at 742,000 miles. Take that off of 4, that's from the center of the sun. So we are approximately 300, not quite 300,000 miles above the sun. And the green dot, the entry point, the pre-entry point, that matches one of Ray's models he was talking about. I don't know where his data points were coming from, but mentioned the 3 models. Then the exit point in the orange, you take 432 off of that, and what you've got, you're less than 100,000 miles above the of the surface of the sun, because you take 432 off of that. So that's the two data points we have. And those are the points that all the different models, and the JPL is showing this model that we're looking at right now. But the data points even it is using is from the green area and the orange area, and so are all the other models. So if you look at the closest approach to the sun, and listen to me, that'll be one of the things on the JPL model. They'll say close approach at perihelion, things like that. You're going to see the data point in green in one model, and that's not the true data point because that's the last one that the models are putting in, okay, right there, because it's moving so fast. But it's an incorrect close approach point. Then the exit point, same deal there. But if it follows the JPL model, we're not going to have that exit point again except for large explosions. So on the right at 510, guys, you are, if you take 432 from that, what are you, about 80,000 miles above the surface? And that is very close, but that's just the exit point. But we don't have the blue line data. And again, all of these data points are to the center of the objects. Remember that. So between 7.993, let's say, and 4.49, or 742,000 or 510,000, there's data arc points missing. But the JPL model, is correct according to this data. And none of the computers, for some reason, are giving us the arc span data. And they're very good, very, very good at it. But let's go from that orbit to the brightness. Now look at this perihelion close approach, minus 10.6. That's the magnitude. And in astronomy, guys, they look at the number of the magnitude to estimate the size of an object. Now today, and this was very recent, magnitude 13.3. And I'm going to show you a picture that's a little newer than that. But the close approach, notice April 4th and April 5th. On April 5th is the exit point. That's showing 2.9, which is very bright. But the 10.6 right before impact, guys, is amazingly bright. And that would be telling me two things. One, it's going to be a huge celestial event. Let me say it like that. And we won't see the exit point, but guys, this thing is we don't know what will happen. In the earlier videos, there's two. The second one I showed you impacts from other comets, or the impact effects of other comets, even much smaller than this, because we're going to look at what a minus 10.6 is going to look like in the night sky. Now they're saying a comet with a total magnitude of 2.7 at 1 AU, that's 100 million miles. That's the distance between the center of the sun and the center of the planet, our planet. It is significantly large and active. While magnitude primarily measures brightness influenced by outgassing and dust, it can be used to estimate the size of the underlying solid nucleus. Estimated nucleus size for a comet at 1 AU, and the closest they can compare it to is Comet Halley at 2.7. And it wasn't a sundiver, so it had a steady brightness. It was so far away, but it was extremely bright. But it wasn't like diving in the sun going to become instantly bright. And this is what it was looking like. It was beautiful. But on this day 39 years ago, again April 11, 1986, says millions of people around the world looked to the night sky to welcome Halley's Comet as it made its closest approach to Earth. The famous comet will return in 2061. And it was beautiful. Many of us may not see it. Many of you may not see it. We'll just have to see. But anyway, that's what it was looking like at 2.7 AU. Very bright. And this is, again, the same distance, basically, that the Earth is from the sun when it came by. So it was a long way from us. But that's how bright it was in the night sky. And this thing is going to be in that range as it approaches the sun. But the brightness just before impact is going to be amazing. Let's take a look at that. Now remember the numbers today. Notice the top line, 13.3 is the number, or that's the magnitude. Smaller the big brighter. Now notice it's at 1.232 AU. So guys, you're over the distance they're saying that it would, they measured Halley's Comet at, and that got them down into the 2.4 to the 2.7, excuse me. Now, this is different. Again, it's approaching the sun. Look at this, April 4th, right before impact, of minus 10.6. Now, again, I don't think we're going to see this number right there.